Hello, thank you for being with us today. Welcome to this Climate Action Accelerator webinar. My name is Pascal Carré. I work with the solution team at the Climate Action Accelerator. Today's topic is how to improve resilience and address water scarcity through innovative solutions. Let's start with few practical information. We have a presentation from 3 speakers today, and we will make sure we have 30 minutes for question and answer sessions. The webinar will end at 2:30 p.m. The webinar is recorded and will be available on replay on our website along with all presentations. Please keep your audio and video off at all times unless you are given the floor during the question and answer session. To ask a question, please write in the chat or raise your hand. I will read question and give the floor to attendees during the question and answer session. Translation will be available via Zoom. For translation, click on the small arrow next to the icon Show Caption, as you can see on the picture. Select the spoken language and the language you want to translate into. I will introduce the Climate Action Accelerator. The CAA is a non-profit organization based in Geneva, which aims to scale up climate action within the international aid and health sector. The CAA supports its partners' organization towards a radical transformation in their practices, enabling them to halve their emission by 2030. They benefit from the close support of the CAA in building their environmental roadmap and action plan, as well as a network to exchange good practices with their peers. "25 organizations have joined the Climate Action Accelerator so far and committed to reducing their emission by 50% by 2030, as well as to reducing all the environmental impact of their action. We are also an official partner of the Waste to Zero initiative of the United Nations Framework Convention on Climate Change. Some key figures about water. According to UN Water, inadequate water supply, sanitation, and hygiene cause deaths of 3.5 million people every year. The situation of water scarcity will deteriorate in the years to come. So half of the world population could be living in areas facing water scarcity by 2025. 7 million people could be displaced by intense water scarcity by 2030. Today, 3 speakers will present innovative solutions for improving resilience and tackling water scarcity. Maria Giovanna Di Bitonto, PDH candidate at Polytechnic University of Milan, will share our research on the fog collection, focusing on smart textile material. Carola Bänziger, environmental scientist at FHNW University, and Sébastien Mercier, project manager at Terre Foundation, will talk about the Gravit'eau hand washing system. Please, Maria, the floor is yours.
Okay, thank you. Okay, do you see the screen?
Yes.
Okay.
Yes, thank you.
Okay, good. So, good morning, everyone. I am Maria Giovanna Di Bitonto, PhD candidate at Politecnico di Milano in architecture at the Department of Architecture, Built Environment and Construction Engineering. In particular, I'm working in the Textiles Hub, which is a multidisciplinary lab focused on the study of textiles. My research topic is fog harvest in textile architecture to face the hydric crisis. So today I'm going to present you an alternative water resource that is fog and how we can take advantage of it, focusing on the integration of fog water harvesting system in lightweight structure design for emergency camps. So as we know, water crisis is becoming more and more serious. For this reason, it is important to study non-traditional water resources. In particular, one of them is fog. Fog water has been documented to be an optimal source of water, especially in territories that lack a water distribution system. This is because fog harvesting is a kilometer zero technology, but I will explain this in a moment. So our proposal is to develop a lightweight textile architecture for fog water harvesting to be integrated into emergency camps. So again, water is fog is an alternative water resource useful to face the hydric crisis in certain areas worldwide defined as fog oases. The extraction of water from fog is a passive system which works by gravity thanks to the fog collector, which is a device composed of a mesh and a supporting structure. Depending on the location and the components, the water collected, the range of water can go from 2 to 22 liters per square meter of mesh a day. And nowadays, the projects developed for fog harvesting, the water is used for agriculture, reforestation, and community use. Even though it's a promising technology, it has some weaknesses, like it is a lone and fragile structure, and the technology has a limited application field. What we are trying to do is to improve its efficiency and expand the application field, for example, in the application of emergency camps. So what is fog? It is a meteorological phenomenon consisting of water droplets suspended in the air. From a physical point of view, when a saturated mass of air reaches its dew point, fog is generated. There are, however, different mechanisms and conditions for achieving this state, for which it is necessary to distinguish fog depending on the formation process. And not all of them are suitable to be harvested with fog collectors. The ones that are useful for us are advection fog and upslope fog, because they are formed by the movement of masses of air, and wind is a crucial factor in fog harvesting. Many territories worldwide are affected by the fog phenomenon, and some of them are located in arid areas, while others are in territories that will face the hydric crisis in the upcoming years. And since ancient times, in arid fog oases, the population adopted to those extreme conditions, and here some sort of a collector has been developed. And the black dots in the image represent successful fog harvesting projects. Actually, the fog oases are way more widespread. Here, the dots represent just the developed projects. So how does the system work? When a humid mass of air is pushed by the wind through a mesh, the tiny water droplets suspended in the air get deposited on the filaments of the mesh. When more and more droplets get deposited, they aggregate. When they reach a certain weight and dimension, they flow down by gravity, and they are collected into gutter and stored into tanks. This is why I'm saying that this is a kilometer zero technology and a passive system. How is the fog collector? Here you can see different examples. Fog collectors are lightweight structures composed of mesh and supporting structure. There are different types of collectors, but just a few of them are applied in real scale projects. Here I'm showing just 4, but there are many others. Those are the most famous. And the most applied worldwide is the large fog collector that you can see in the first image, and designed by FogQuest. Generally, the mesh used in the majority of the collectors is the Rachel mesh, which is a common textile used in agriculture for greenhouses or in construction for the scaffolding, for example. The structure of the collector can be bidimensional, that is the most common, and you can see it in the first 2 images, or three-dimensional, that you can see in the last 2 images, and this is used when there isn't a main wind direction. So as you can notice from the graph, the quantity of water collected may vary from location to location. Here, for this graph, all the tests have been developed with the same mesh and structure. So it's just a matter of meteorological conditions of the location. So now that we know how fog harvesting works and the device useful to collect water, I'm going to present you why and how we want to apply this technology to emergency camps. Generally, in emergency, water is extracted by near surface waters like rivers or lakes, which are often contaminated, or from underground aquifers. And when a water source is lacking, it is provided by water tank trucks. And a remedy for these difficult situations can be fog harvesting. In many areas affected by extreme event in need for emergency camps, they also correspond to fog oases. So let's focus on a moment in the areas of high seismic risk. We can see all that the west coast of South America up until California, together with Japan, these areas are affected by fog, and many projects have been developed successfully here. But also these territories are part of the Ring of Fire, so a seismic and volcanic zone due to the subduction of plates. Also in Middle East, like Syria, Palestine, and Iran, there is a frequent need of emergency camps, and here not only for natural hazard. In any case, what is common in the majority of emergency camps is that they are located in remote areas because the cities are not accessible anymore or they are too dangerous to live in. So the camps are missing a distribution since they are located in rural areas. They are missing a distribution system regarding both water, but also energy, food supply, and waste management. And what we are trying to do is to give a response to the lack of the hydric system. So we have seen that the fog collector is a very simple structure, and we are envisioning the integration in emergency camps, and we analyze some tents. We took as a reference the multipurpose tent designed for the Speed Kit project by a collaboration between Politecnico di Milano and Ferrino. This tent is already used in many projects. A single unit can host 5 people and is composed by steel poles and joints, all equal. All the connectors are the same, but just by rotating them, you can achieve different angles to create the roof, for example. And this is due to facilitate the setup in emergency context. What we are looking for in this study of tents were ways to integrate 2 systems, so the sheltering and the water provision. And we noticed that a simple bidimensional fog collector can be applied in many cases, just integrating it using the elements already required for the assembling of the tents. And this is useful because we can apply this technology in already existing camps with this type of tents, but also in new ones. So here you can see how the camp should be organized. All the tents should have the same orientation, which is perpendicular to the wind direction. And also the shelters should be organized in blocks, and each block has 2 water tanks. The first one, the smaller, is dedicated to the water collection of primary use of the inhabitants of the block, while the second is filled after the first one and is used for the common services as the canteen. This represented in blue is the joint that we designed. We created a prototype using a 3D printer. It is a very simple joint and easy to install, to use, and to maintain. And this joint can be inserted in the steel parts, in the steel connectors of the tent, of the multipurpose tent. And thanks to its design, we can rotate it. So as you can see in the image, when it's standing up, it functions as a fog collector, but by rotating it, it can provide like a shading roof for the external part of the tent. We developed an analysis of different territories. Here I'm reporting one of the Sahel region in sub-Saharan Africa, which is also the area where some camps that use the multipurpose tents are located. As you may know, this region suffers of intense droughts, but also in the last few decades, it's affected by rainy periods. And some fog harvesting projects have been developed here, in particular in Eritrea and Ethiopia. So even though it's a very dry region, we can take advantage of the atmospheric water, so rain and fog. The water requirements in emergency situation per person is 15 liters. And in Eritrea, from the literature review developed, it emerged that we can have a collection of 3.1 liters per square meter of mesh a day of fog. And if we sum up also the quantity of water that we can collect from the rain, collected both from the fog collector applied on tents, we can obtain 16 liters per person a day. So even more respect to the standard requirements. We developed another analysis in Haiti, and here the collection of fog water is reported of 5.5 liters per square meter of mesh a day. And in this case, just from fog water, we can obtain 22 liters daily per person. Which means that the inhabitants can use the water also to develop some activities or small businesses other than just survive. And from an economical point of view, the cost of a large fog collector, the one that I presented at the beginning, the most common one, is about $1,500. And we can assume that the cost of the structure proposed for the tent are almost the same. Like the collectors we propose are smaller, but there are more engines, so it should be equal the price. And considering a lifespan of 10 years for both the mesh, because after some exposure to sun and wind, it degrades in 10 years, and the permanence of the temporary shelters, because the tents should be temporary. We can have the cost per liter of the water collected should be less of the current market price of water in this area to be competitive. However, it's slightly higher, but in any case, from an environmental point of view, fog harvesting is more convenient because it doesn't rely on energy to function or on water tanks that are supposed to come to the camp. Regarding the quality of water, many tests have been developed worldwide on the water collected, and generally they meet the standard of the WHO standards. So it doesn't require a filtration system, and it's also less risky to use. Of course, in any case, when we are going to implement a new project, some primary tests should be developed on this water. It usually is not contaminated unless the location of the camp is located near a polluted area like factories or like this. Regarding the mesh, here there are some examples. In my research, I've tested many meshes, both in the field and in the lab, to test the performance of these meshes. The most used is the Rachel mesh, and that you can notice in the first image, the one used in agriculture. And between the mesh tested, there is also the mosquito net and some spacer fabrics. Considering the price, the mosquito net costs as much as the Rachel net, but it collects almost the double amount of water. And the spacer fabric costs 10 times more than the Rachel mesh, but it collects 5 times more. But it's also more resistant, so it can resist more than 10 years. So depending on the location condition and on the requirements of the project to develop, on like the lifespan of the project and the budget, a different mesh should be selected. And I must underline that the mosquito net used for this type of project doesn't have the repellent treatment on the surface, so is safe to use. And to conclude, water is becoming more and more a scarce resource. It is defined as the blue gold of the 21st century. And in this scenario, fog stands as an optimal alternative resource in location in fog oasis locations. So we should give it a try to this new technology. Thank you.
Thank you very much, Maria, for this very interesting presentation. It's really something we have to think about. Your presentation is clear with a nice figure and very complete. We have already a question in the chat, but we will go to the question at the end of the webinar.
Okay.
For now, we will give the floor to Carola and Sébastien for the presentation of the Gravit'eau system. Go ahead, Carola.
Hello and good afternoon from my side, at least for those who have afternoon right now. My name is Carola Bänziger. As already said, I work at FHNW. I work on different applied research projects in the wash field in many different countries. And why now on the title it's not written Gravit'eau but Hands for Health is because for us it's very important to not have a look at the Gravit'eau station isolated, but rather to give you the frame of the different things to consider, and therefore we will present you our project called Hands for Health, together with Sébastien Mercier from Terre. So the Hands for Health project is a project focusing on hand hygiene water quality and sanitation in primary healthcare facilities and schools that are not connected to a functional water supply or not to a municipal water supply. In this project, we work with a big consortium on one hand from academia, but also the private sector and international NGOs. We work in 4 countries, in Mali, Burkina Faso, Nigeria, and Palestine. In Mali and Burkina Faso, we work in primary healthcare facilities. In Nigeria and Palestine, we work in schools. And as said, the institutions are not connected to a functional water supply, and therefore the whole issue with water scarcity or not that much water available plays an important role. The objective of our project is to have a systemic approach to hand hygiene, water quality, and sanitation adapted to the local context and needs of users and implementers. Therefore, we work on different pillars. On one hand, on technology and infrastructure based on already existing technology, but also innovations such as, for example, the Gravit'eau station, and to figure out what is actually possible to do on local production. We work on data management and monitoring with different assessment tools, but also with online monitoring and platforms. On the social science, we work on behavior change and user-centered designs. And all of this is integrated in a health impact evaluation. And last but not least, which is very important for us, is to have the stakeholder engagement on national and international level, but also on local, regional level with authorities and other organizations. And in the end, we want to have an integration of the existing tools and novel washing interventions into a practical, user-friendly tool. So when we talk about these tools and intervention, for us, we started with an assessment with FACET, but also with theory of change to really try to figure out what are hindering factors and problems that these institutions are facing. Based on that and based on existing tools, we came up with a combination and setup of different interventions, on one hand on the hardware side, but also on management and monitoring and on behavior change. And what we're going to do is to lead you through these different interventions with a main focus on the Gravit'eau hand washing stations. So with this, I give over to Sepp, who will present you the Gravit'eau stations.
Hello, everyone. So yes, I'm going to present you the Gravit'eau hand washing stations. So as already mentioned, the Gravit'eau station is a hand washing system that recycles water. And maybe Carola, you can click next to start the video. It should work so that I can explain how it works. So it's a hand washing system. It's activated by a foot pump. And so by activating the foot pump, water is brought from the clean water tank to the tap. People wash their hands, and then the used water is collected by a sink, and then it goes through a couple of filtering stages. So first is that sand and grease trap, which removes most of the floating and sinking stuff. And then water goes through this membrane tank, which contains the principal component of the system, which is this filtering membrane. And the filtering membrane removes most of the finer stuff, in particular microorganisms. And then this filtered water is clean and safe for hand washing, and it fills back the clean water tank. and so it completes the cycle. So that's how the system functions. Now, what are the specificities of the Gravit'eau hand washing system? As already mentioned, water is recycled, and in particular, water is recycled only through gravity, hence the name Gravit'eau, which means that no electricity is needed for this process. Basically, the only source of energy is muscle energy that you need to activate the foot pump. And since water is recycled, a water replacement is only needed every couple of weeks or so, depending on usage. And this greatly reduces water transport in places where water is not available. So all of those aspects, no electricity needed, no continuous water supply needed, those are valuable assets for a system to be used in water scarce areas and remote areas, which is where we work, where we implement those systems. And from our experience and evaluation, we can say that roughly 97% of water is saved using this system compared to conventional hand washing systems. Next, please. So I'm going to talk a bit about the construction of the Gravit'eau stations, because one key aspect of our intervention is that we want those Gravit'eau systems to be as much as possible built locally. So for that, we have contracted workshops in our countries of intervention, Burkina Faso, Mali, and Nigeria. So those local workshops, the staff has been trained, and they build the system. So only small parts and the membrane module are imported from Europe. So we send those materials, but the workshop, they build the housing and they assemble the whole systems locally. And in the course of this Hands for Health project, we have already built over 100 stations and deployed them in healthcare facilities and schools. Next. Now, installing the stations is the first step. Then we need to make sure that they are properly maintained and monitored. And this is done by having a Gravit'eau focal point in each school or healthcare facility. Those people are trained and they know they are in charge of maintaining the systems, that is cleaning the systems regularly and refilling the system with the fresh water when needed. And so we train them, but we also have guidelines that have been developed. Not only we've developed guidelines for constructions already for the workshops, but we also have guidelines for the maintenance and also for monitoring, because we also need to monitor those Gravit'eau stations, and this is done by the Terre des Hommes teams in each country. So they have a series of tools to do regular tests on the water quality and also the integrity of the membrane. We have a specific test that makes sure that the membrane is not damaged and that the water is properly filtered and safe to use for hand washing. And so we have procedures for that and specific electronic questionnaires installed on mobile devices such as smartphones or tablets. And they use those questionnaires to collect data, and then we have those data automatically aggregated in an analysis system, and so we can monitor all the systems in our project that way. So that's it for the Gravit'eau stations. I'm heading over to Carola again for the other aspects of the project.
So once we have these hand washing stations, we want also that the people actually wash their hands and that the hand washing stations are used. So that's why we also have a behavior change intervention, which is based on the RANAS behavior change. I'm not going into too much detail what RANAS is, but basically there are preconditions that need to be there. So there need to be the possibility that people actually can wash their hands. So this we can ensure with our hand washing station. And then based on this RANAS approach, we evaluate what are the differences between people that do a certain behavior and others that don't. So what's the difference between people that wash their hands and and people that don't wash their hands? And based on that, there is a very specific catalog of activities of which targeted interventions are done. And you can see here some pictures of these RANAS interventions that took place in schools and also in healthcare facilities. Other than that, for us, it's very important to have preventive maintenance and rehabilitation. So to ensure that the infrastructure that is there exists on a long term and is maintained, there is regular inspection and maintenance of people, on one hand for the Gravit'eau station, done by the Gravit'eau focal point, but also with having support, external support, as soon as repair is needed. We also work with staff that are trained to do repair, that then can cover multiple institutions and support there on the repairs. In Mali and Burkina Faso, we implement WashFit. WashFit is a risk-based management approach for healthcare facilities, and it's built up on a WashFit team that is built with staff from the healthcare facilities, but also people from the communities, and together they ensure they take over the responsibility of managing all the wash infrastructure. So they make sure that there are the finances, and that there is also regular management and monitoring of everything within the wash of these healthcare facilities. What we achieved is that the Gravit'eau management got taken up also in this WashFit, and in Mali, the WashFit is part of the national standard for healthcare facilities, and in Burkina Faso we are working a lot on that. This also gets taken up by the national authorities. That's a lot on management and maintenance part. Other than that, the water quality is an important aspect for us. Therefore, we work on chlorination. So first of all, we evaluated the water quality in schools and healthcare facilities, especially in healthcare facilities. For example, in Mali, there are regulations that the water should be chlorinated, but actually it's not done. So we were evaluating a lot what are the challenges behind the chlorination and why it's actually not done. And we figured out that's a lot connected to dosing issues. So we conducted training of trainers so that the regional health directorate could then go into the healthcare facilities of our project and train the healthcare staff. We established a digital collection tool that transfers real-time data and visualizes it. And we established the chlorination at the school and healthcare facility level. We are there in the context of the chlorination, also a lot in dialogue with the ministries, with the Ministry of Education in Palestine and with Ministry of Health in Mali and Burkina Faso, and to try that it gets taken up into national guidelines. And on that slide, I would like to give you an insight on what this chlorination monitoring tool looks like. You can see here schools in Palestine that are measuring the free residual chlorine concentration. And with that, now the Ministry of Health can also monitor if they check the chlorine concentration, but also what the level of chlorine is. And based on that, further actions can be taken. So, as I mentioned earlier, this is all part of a health impact evaluation. Therefore, we did a pre-assessment and then a baseline data collection of 26 institutions per country. It got randomized and half of them received an intervention, which is currently happening. So this combination of different interventions really targeted to their needs, and the other half of the institution are the control group. End-line data collection is about to happen now, or is starting in 2 weeks, and then after that the control schemes will then also receive the intervention, or at least the intervention that actually worked. And the last thing that I would like to let you know is that based on all the things, on all the combination of intervention that we are implementing, we are developing a catalog and improvement planning tool that consists of all these different kind of intervention, and that we can also share our experience, for example, on the chlorination, but also on the Gravit'eau and so on, that it can be used by anyone. So with this, I would like to end, and we are very happy to answer any question related to the whole Hands for Health project, but also specific to the Gravit'eau. And if we don't find enough time to do that now, we're also happy if you contact us via email. Pascal, you're mute.
Yeah, thank you very much, Carola. Thank you, Sébastien. It was very interesting presentation. Very nice, very nice. We will go to the question and answer sessions. For the participant, please put your question in the chat if you have some. We have already 2 questions. The first question, we will start with Gravit'eau, maybe, because we just spoke about that. From Alexa, do the filter need to be renewed? If so, how frequently?
Thanks a lot for that question. So, maybe to be more specific, so as you saw, it's like the filter element are flat sheet membranes, and they don't need any backwashing. As soon as there is accumulation of particles, that will fall down, and it can stay like that for quite a while. So there are estimations how long it can be used, and based on our experience, they should be able to be used up to 8 years.
Okay, thank you very much. Maybe a general question of Gravit'eau. Do you have can you give us an idea of the price of a single system like that, or maybe it depends of the place? Can you give us an idea of the cost of the Gravit'eau system?
Mm-hmm. Yes, as you already said yourself, it depends a lot how it is produced locally in the end. You could see on the pictures There are some which were made out of wood, other made out of metal, depending on what is locally available. Current price is around 800 euros. I don't know, Seb, if you have other numbers. Yeah, it's around that.
Yeah, I don't know that we have any clear estimation for now, but I would say around that, yeah, around that. And as far as I know, that the most expensive part, let's say, is really the membrane module. It also probably depends on the size of the module, because depending on how much water you need per system, you would buy filters of different sizes. But that's a significant part of the cost of the system. But then again, material and local availability of components plays a role in the final price of the devices.
Maybe to add on that, currently the membranes are produced in Germany, and every single module gets tested. So it's really like the quality of the membranes, the standard is quite high, and therefore it's also quite challenging to have like local production of the membrane module. And then explanation for the price.
Okay, for now, there is a local production somewhere of the membrane, or it's only coming from Germany?
Yes, the membrane is coming from Germany and some connectors, and all the rest is built with local available materials. Okay. I mean, it's also important to say we are recirculating the water, so it really, we want to be sure that the bacteria get retained by the membrane. That's why the quality of the membrane has to be quite good.
Yes, sure, I understand. I will go back to the question from the participant. Maybe a first question from Clotilde. What are the challenge and convenience you see with Gravit'eau system? The main challenges of Gravit'eau?
The main challenges, we are always trying to tackle the main challenges and optimizing the system themselves. We saw we had challenges with the emptying of it and the cleaning of it, which now got a lot improved. There are of course also challenges that are connected to that the people trusting into the system. Yes, Seb, do you want to add?
Yeah, depending on context. I mean, there are obviously logistical challenges that we discover and we learn to deal with. We get experience on that. But also depending on the context, there could be security challenges depending on the areas where we work. That happens. We had during the course of this project, we had to switch places. We had identified some healthcare facilities that we at the beginning that we had to give up because the security situation became too critical. So those are the kind of challenges that we faced during the implementation of this project.
And maybe one thing to add on challenges are also with vandalism, really depending on the context. For example, in Nigeria, in schools, we were vandalism was in some schools an issue. So then it also depends a lot where you actually place the Gravit'eau station. Is there any kind of guard and so on? So this can also be a challenge, or a challenge that we faced.
Yes, and this highlights the fact that it's not only the implementation of the stations, but also all that gets around it, like organizing, as Carola said, security maybe, or making sure that the stakeholders are engaged in order to make sure that everything goes as smoothly as possible.
Okay, thank you very much. We will have a last question on Gravit'eau, and after we will go to Maria. So we have an interesting question from Cedric. Do you know the years of return on investment of Gravit'eau comparing with water saved and price of investment? Do you have an idea about that? The return on investment?
To be honest, I don't really have, because in the context we are now in this project using the Gravit'eau station, people are getting the water from a borehole for free. So it's like hard to quantify that, or at least I haven't done that. But we can really say that there is a lot of water that is saved. In some of the current versions of the Gravit'eau station, there are 90 liters inside, and this water can stay in there for, it depends a lot on the use, but it can stay in there for 2 weeks or more. And so if you then calculate with 200 hand washing events per day, and if you would calculate for the same number of hand washing events how much water you would need if you use water that only gets used once, you can say we end up with a calculation of around 97% of the water that is saved. But yeah, I cannot answer the question in regard of return on investments. Seb, did Terre des Hommes do any calculations like that?
Well, I was just asking Bruno in parallel about that because I saw the question. But as you mentioned, it probably depends a lot on what's the local price of water. So as you said, the process would be to know how much you would save in a particular context. You should evaluate how much water you would save, and based on the price of water locally, whether it's water trucking or other forms of having water available, then you could calculate how much money you would save and compare that to the price of implementation, I guess.
And maybe one thing that we haven't mentioned now, you can imagine compared to another hand washing system that needs to be also manually filled, you need less people that actually go and get water and transport it to the place where it's used for hand washing. And I think like that's also something that needs to be taken into consideration.
Okay, yes, sure, I understand. Thank you for this answer. Thank you very much. We will go to Maria with the fog harvesting. The first question was regarding the camp, the refugee camps from CM. For camps in countries facing extreme heat problem, it's the average also 15 liters of water per day as well. Do you have a range, Maria?
It depends, because there are many guidelines telling how many liters a camp should have. 15 liters is from the World Health Organization. So, and these are general data. I guess that having more, it depends on the situation. But of course, having more, it would be better.
Okay, and if the camp face extreme heat, the fog harvester are able to produce this kind of amount of water?
Yes, like the advection fog is formed when the humid two masses of air of different temperatures meets. So higher is the temperature on the soil, and the temperature on the sea is less, it creates even more fog. The fact is that this phenomenon happens mostly during the night and in the morning. Then when the sun rises and the heat becomes a lot, fog disappears, like evaporates. But during the night, you probably know that in the desert during the night is very cold. So it's not a problem that the camp face extreme heat. And regarding the mesh, it's all of them, they are UV resistant, so is not a problem.
Okay, I see. I note another question from TM for you, Mariam. Has the fog water harvesting system been used outside of camp context for farmers facing extreme heat challenges, for example?
Yes, like fog harvesting, I'm proposing the adaptation to emergency camps. They are not currently used in emergency camps. They are mainly used in agriculture. And they are used in agriculture in Morocco, in Canary Islands, in Chile, in Peru. So yes, it works. The same as for emergency camps. The fog is usually forms during night, early morning. So during that period, you collect water and then you use it during the day when it's very hot.
Okay, as far as I see, for agriculture, the fog harvester are just put on the field,
Exactly.
directly on the field.
Yeah. Yes, it's a very simple structure, two poles and a mesh between them.
And the water go directly on the earth. I will add a personal question. In urban context, do you have some experience in urban context for fog harvesters?
We are studying it. We think that in some areas we can collect water from fog, like in cities like San Francisco or Dubai, Abu Dhabi, which are quite desertic areas, but since they are on the coast, they can get fog from the coast. We studied some system to apply the fog collecting panels on facades of buildings, but since it's more complicated, the mechanism, because the aerodynamic flow of wind in urban canyons is different than in rural areas. It's under development, let's say.
Okay. Yes, I think it's a very good experience. Another question for you, Maria, from Benjamin. For the fog collectors, is the water yield you present the standard across all regions tested? What about regions with little to no precipitation?
And there are many, the quantity of water collected by fog really depends on the location. So whenever you want to start a new project, you should develop a test campaigns to understand which is the potential of the place. And here I presented two examples, one in Eritrea, in which the quantity of water collected was a sum between rain and fog, but the other in Haiti is just fog. They don't have much rain, and just with fog harvesting, they can survive. So it also depends on the mesh you're using and the type of structure, because if you're using the Rachel mesh, you get the minimum. If you use like a spacer fabric, you can get much more. So there are many variables that play roles in the quantity of water that you can get.
So I have another question from Alberto. How to avoid harvesting dust while harvesting fog? This is the problem with dust, mainly in a desertic area where it's really interesting to get water from fog. What about the dust?
Yeah, exactly. You don't have dust in all the location, like just in the desertic ones. And I guess just with a mechanic filtration, like with a membrane, you separate them.
Okay, we have to mix Gravit'eau system with
Exactly.
fog collectors. We have to use
Yes.
the same membrane. I have a question from Carola for you, Maria. Do you know how prediction of fog development with climate change are in the future?
It's a very tough question, this one.
Yes.
I guess in some areas it will disappear or become less frequent or less intense, the fog phenomenon, but I also think that in other areas it will increase. So maybe they are gonna move, but they are not gonna disappear. Because as I was saying, it's formed by the different temperature of the air upon the soil and the air upon the ocean. So rising the temperature on the soil will still provoke fog phenomenon. But if the water currents in the oceans change, that is a problem. Like I cannot understand. For example, in Chile there is the Atacama Desert, that is the most arid desert in the world. So very high temperatures on the soil, and on the water in the ocean there is the Humboldt current, that is a cold water current. So these different of temperatures makes fog. I guess that it will change, this scenario will change, but telling where you're gonna find it, I don't know, difficult. Like, and also I'm an architect, I should we should ask this to a meteorologist or geographer, I don't know.
Okay, thank you. I will come with the same question we have for the Gravit'eau system. What are the main challenges or inconveniences with fog harvesting?
I'll start if you want. Challenges is referring to fog harvesting in the application of emergency camps. Everything that I said until now, it's a proposal. Like I took real data from real tests, but nobody applied the technology yet in emergency camps. So this should be verified with some field test. This, after that is being verified, I guess it's a quite straightforward process of application. But there we might find some challenges in the organization of the camp, because all the tents should be, or at least all the collectors should be perpendicular to the main wind direction. So this is more, even though you can apply this technology on already existing camp, it's easier in new camps because you can organize the site. This might be an inconvenience in the development.
Okay, I see. I have another question. I don't know if you answer already. About the quality of water collected by the net. The water, is it okay in terms of composition? Is it possible to drink this water for all the time or among a long period?
The water, many tests have been developed on fog water collected, and it's feasible it meets the drinking standards. But of course, anytime that you want to apply a new fog harvesting project, you should test the quality of the water collected in that specific region. Because, for example, if you are near, like I guess in urban areas, for example, the quality of the water it won't be very good. So it depends on the location. The majority of the tests have been done in water collected from rural areas, and it was good, but it depends.
Okay, a last question for you, Marianne. After we will go back to Carola and Sébastien a little bit. What will be the way to replicate and to scale up the system of fog harvesting? You see, it seems interesting. I guess a lot of people, lot of farmers can use this system. How to scale up the fog harvesting system? How to replicate it?
I guess it depends on the location you are in the not just the location itself, but how you can organize the urban settlement, let's say, also depending on how much water you need. There are in the designing, so in the designing of fog collectors, there are many variables, like the materials that you can use, the budget that you have, so you can have fog collectors from 1 square meter, that is the standard for the test, to 50 square meters or even more. I guess that you can use it for agriculture, you can use it for emergency camps, you can use it for reforestation, but it really depends on the constraints of the location you have. So it's difficult to generalize.
Yeah, okay, I understand very well. Thank you very much. We have a question. We have another question from for Carola and Sébastien from Clotilde. Could we have Gravit'eau for dishwashing or other use than hand washing? Did you try it?
Yes. So the thing is, and that's something that we did not mention before yet on the challenges, the thing is that we do not remove soap with the Gravit'eau station currently. And therefore, or in general, we try to avoid to have too much organic input into the system, and therefore this recommend to use it for dishwashing. Seb, you also unmuted. Did you want to add something?
Maybe I can, because actually, since I saw the question, but I thought that we were done with our side of the question, I answered directly to Clotilde in the chat. And I mentioned that, in fact, Gravit'eau is intended for hand washing only, that the water could not be used for drinking. And also the design takes that into account, that the tap is made in a way that to try and avoid as much as possible that maybe, for example, children would try and drink from directly from the tap, but also there are signs on the stations that indicate that water should not be used for drinking or dishwashing. And so she was asking me if there might be, she was asking in the chat if there could be other application of that, like for dishwashing or other uses. And I said, but Carola, you could confirm that I think at FHNW you might be working on household filters as well in other projects. I wasn't sure, so I told Clotilde that she could contact you about that. But yeah, Gravit'eau is specifically for hand washing, and other users should use other systems.
Mm-hmm. Yeah, exactly. The membrane themselves, we use them already to treat drinking water, since it's it can treat also the water for drinking, but then the setup obviously would need to be different. And I mean, the Gravit'eau hand washing stations we're talking about here, they are really used in institutions, so in school or healthcare facilities or in child-friendly spaces in camps or in detention centers, they have already been implemented. So yeah, I think like the system itself in the current design is really for hand washing and to increase hand hygiene.
Okay, I understand. But on another side, it may be possible to use this kind of system with another design for drinking water, for example.
For drinking water, I would disrecommend to use the recycling of the water, but to have like the same membranes in a different setup, you could use it for drinking water. Yes, definitely. And I think like for dishwashing, there are other ways of reusing that water. I know of approaches of using the gray water from washing dishes to irrigate. Yeah, for example.
Okay. So another question for you. I know a little bit the answer, but it's out that it's important. What else benefits have been proven for children from the use of Gravit'eau, and how are you able to prove it? We have health benefits. Did you have some studies about the health benefit of Gravit'eau?
I'm not sure I understood the first question for the kids correctly, but we adapted this design in the sense that it's the one in schools are much lower, and we were also testing if kids can use the pump themselves or whether someone else needs to be pumping, that it's really adapted to or adjusted to kids' needs. Was that your question for the kids?
Okay, not exactly. By the use of Gravit'eau, we will avoid a certain amount, certain diseases.
Yeah. No, on health. Yeah.
It's about health. And how did you do some studies to compare the health of the children with Gravit'eau or without Gravit'eau, and to measure the benefits?
Yes, that's part of this study. So to measure the health impact, it's very challenging to measure health impact in general, since like there are a lot of factors playing a role on health impact. Within this study, like what is measured for health impact is we do hand rinse samples to measure bacteria on the hands of the children. There is also evaluation of absenteeism of students, for example, at school, and healthcare staff at work related to them being sick. Yeah, so we're trying to do that, but there are a lot of challenges with doing health impact evaluation. And for that part in our study, there's also the Swiss Tropical and Public Health Institute, like doing the health impact evaluation. So we are trying to do it, but it's not so easy. So if others here have a lot of experience with doing health impact evaluation based on hand washing, that would definitely be interesting to have an exchange on that.
Yes, I understand this difficulty for sure, for sure. Maybe a more general question. If my organization would like to install a Gravit'eau system, what needs to be considered and who could provide technical support? If somebody, NGO, local NGO wants to install a Gravit'eau system, how to do?
The Gravit'eau there is technical support from Gravit'eau, which is an association, and also from our end, from FHNW, and obviously also Terre des Hommes can provide sharing their experience. What are requirements? I think like Seb, do you wanna add on that, because you have a lot of experience with what were the requirements where you established it newly?
Yeah, I mean, we're learning as we go still, but I would say properly planned project first of all, because as I mentioned, it's not only receiving a hand washing station and putting it somewhere, installing it in a facility or in a community. So that involves planning. I mean, there are prerequisites like planning where the Gravit'eau stations would be needed, making sure that they would be maintained, having them built, make sure that they are properly maintained and monitored, because you want to make sure, or at least we do at Terre des Hommes and FHNW, we want to make sure that the water stays safe. So we need to make sure that they are properly they are not damaged and function properly. So there's some involvement in that. But yeah, it's an investment to make sure that the projects have a real impact.
Okay, and if I understand well, in some countries where you worked already, some people are able to build some Gravit'eau system in Mali, in Nigeria.
Yeah, so our teams locally in Nigeria, Mali, and Burkina Faso, our local teams at Terre des Hommes, they have put out how do you say, a bid, I guess, to get offers from different companies to build those systems. And so there was a list of requirements that those workshops needed to fulfill, to make sure that they were able to build what we need, and with a high enough quality, and then exchanges with the identified or the chosen company to have first a prototype built, and then with advice from the Gravit'eau Association and their expertise, making sure that, or adapting the prototype to correct maybe things that were not designed properly. And once a prototype is decided on and validated, then we can start manufacturing at a larger scale. And so yeah, we've identified 3 workshops in those 3 countries, and have already ordered several batches of Gravit'eau stations from them for our implementations.
Okay,
Maybe
very good.
Just
Yes.
sorry, just to add one requirement. I think one thing that is crucial, that there is actually a need for the Gravit'eau hand washing station. I mean, in a setting where there is a running tap with water, no one will use a Gravit'eau station. So
Obviously.
there needs to be a need for having a hand washing system like that.
Okay. Yes. Yes, I understand. Okay, thank you very much. I will ask the same question with to Maria. If my organization would like to install a fog collector, what needs to be considered and who could provide technical support to a local organization?
Me, me
You.
and the textile sub, we like the tent that I showed before that exists and it's already applying in many emergency camps. We designed it. So like now designing the like a supplement part of the kit, I guess we should do it. Like if somebody's interested, since it doesn't exist on the market and we design it, they should contact us.
Okay, okay, interesting. You say it was applied in refugee camp. Where exactly?
In Burkina Faso.
Okay,
And other areas of Sahel region, but I remember just Burkina Faso in this moment.
okay, okay, good. So we don't have any more questions in the chat. I don't see. So we can close this webinar. If there is no other question, thank you to our speakers, thank you to Maria, thank you to Carola, thank you to Sébastien. It was very interesting. I think we will send you some partners. It's really interesting. Please look to find further information about the work of the Climate Action Accelerator. You can find, you can see on our website. We have a solution hub where we place different solution on reduction, environmental solution, on reduction of carbon footprint. So look at our website. You have the address in front of you. So thank you to everybody, to the speakers and to all the participants for joining us. And we look forward to seeing you for our next webinar in a period of 1 month, more or less, something like that. Thank you. Goodbye.
Thank you. Bye-bye.
Thank you, everyone. Goodbye.
Bye.